Hello, math lovers! In this lesson, we will learn about exponent rules. In previous lesson, we learned about exponents, or we call it as power. So we need to know these exponent rules because the rules we are using for simplifying expressions. For this case, like multiplying exponents with the same base, this rule calls product rule. If we have expression that has this kind of numbers like unknowns with exponents or numbers with exponents, we know that if we have same base but different exponents, they are multiplied together, we can write the base as same and add the exponents. Let's do the example. If we have 2 to the power of 3 times 2 to the power of 4, we can write this as 2 and 3 plus 4, which is equal to 2 to the power of 7. See, we had this kind of expression, and now we combined it and got 2 to the power of 7, which is very easy to count. So this rule was product rule because they were multiplied. Now let's see quotient rule. As I teach you before, remember we call the answer for multiplication product. We call the answer for division quotient. So now let's do a to the power of m divided by n to the power of n. We have the same base. Let's do with numbers. 3 to the power of 4 divided by 3 to the power of 2 equals to, in this case also we can write the base just one time, 3, and subtract the exponents on top, 4 minus 2, which is equal to 3 squared. And this rule we call quotient rule. In next case, what if we have different numbers but they have same exponent? Like we have 5 over 8 and they have same exponent. Let's say they have here 7 to the power of 7. How can we solve this? We can do this way, or one can be unknown, one can be number. We will do this way. It's gonna be 5 to the power of 7 divided by 8 to the power of 7. This one we call power of quotient rule. This one was quotient rule. This is power of quotient rule. We have here division. That's why the answer will be quotient, but we have power of this quotient. So this is another way. We had different bases but same exponent divided here. That's why we can separate the exponent for both of them. It will be correct answer. Next one is power of a product rule. Same way as we did here for division. Now let's say we have different numbers, 6 over 7. 6 times, let's do again, 6 times 7 to the power of 9. We can write this as 6 to the power of 9 times 7 to the power of 9. So this one we call power of product rule. Multiplication's answer is product. So this is actually a product. 6 times 7 is a product when you answer it. And it became to have right 9 as an exponent. So we can separate them. 6 to the power of 9 and 7 to the power of 9. So this was power of a product rule. Like the first one was product rule. This one is power of this rule. Next one, this is very fun. It's easy. If you have A as a base, M power, and another outside of the parenthesis, you have another power. You just multiply these two together. Let's do it in example. If I have here 9 to the power of 2 and then another power of 3. This is very easy. We just multiply these two numbers. It's going to be 9 to the power of 2 times 3, which is 9 6th power. So those are very important. We use them in many expressions, problems. This is basic part of exponents you need to memorize if you want to continue to learn math. Okay, next one is zero exponent rule. As we talked in previous lesson, types of exponent, we had this. A to the power of 0 equals 1. This is any number, 9 to the power of 0 equals 1. Let's do some example here. Example. If I have 2 to the power of 0 equals, I can use different methods, previous methods, like 2. Let's write 3 minus 3. Imagine we had same base, 2, and m and n were 3. So in this case, I will have like this is this one. When we divide, we can subtract. I would write this as equals to 2 to the power of 3 and 2 to the power of 3 divided equals, this is 2 times 2 times 2 divided by 2 times 2 times 2. Same thing divided by same thing equals 1. So 2 to the power of 0 equals 1. We don't need to solve this. I just showed you an example. Just remember, any number to the power of 0 equals 1. Except 0, we cannot write down 0 to the power of 0. This is unknown, not decided. Okay, this is for 0. And the other one is negative exponent rule. We saw this in previous lesson too. Like when we have negative, let's say 4 to the power of negative 2. We're going to write this equals 1. We call this inverse. 1 over 4, base remains the same, but the exponent becomes positive. 4 to the power of negative 2 equals 1 over 4 to the power of positive 2. And the last one is fractional exponent. In last lesson, we also call this a rational. Fractional exponent, if we have 2, 1 over 3. This will become square root or any root. If here we had 2, it would become square root. If here we have 3, it will become cube root of 2 comes inside. Base always remains the same. And this becomes power here. Just we have 1, we can put 1. If it was Like say 4, we could put here 4. Okay, this is about exponents rules. We're gonna use them many times in future. Just practice or try to memorize. Thank you for watching. Have fun. We're gonna go all the way to the hard maths. You just need to learn multiplication table and learn these rules. Have a nice day. Bye.